Welcome to your geometry recording for the week of March 8th. Just a reminder to have your math notebook out so that you're ready to take great notes and try some problems that will help you when you go to do this week's assignments. So I do have a warm-up problem that I did want to start with where we've got a figure down here below that we want to find the area of. So we've got a quadrilateral, and the dimensions are given with a variable, and you need to find the area. So go ahead and do this in your math notebook, and when you're ready to check your work with mine, go ahead and click play again. So pause the recording so you can try the practice problem, and then click play when you're ready to check your work with mine. All right, so we know to find area of a parallelogram or a quadrilateral, I should say, rectangle here, is to take area equals base times height. And we are going to go ahead and multiply our base, which is x plus 5, times, or I'm sorry, the base is actually x minus 3. The height would be x plus 5. All right, so we can go ahead and distribute. So let's go ahead and distribute. Remember, that means we are going to take the first term in the parentheses, multiply it times the first term in the second set of parentheses. So x times x is x squared. Then we take that first x and we multiply it by the second term in parentheses. So x times 5 is 5x, and then we do the same with the second term, that 5. We're going to take 5 and multiply it times x, which again is 5x, and then 5 times 5, which is 25. And last but not least, we need to just combine our like terms. So I see that we've got two x terms. We only have that one x squared term hanging out in front. We've got two x terms. 5x plus 5x gives us 10x. And we've still got that 25, and we can no longer combine any other terms. So we are done. So this would be our final answer right here. Great. So let's go ahead and move on and take a look at what we're doing this week. So this week it is a lighter week of assignments. So this is a great opportunity for catching up if you're behind in the class, or redoing any low-scoring assignments. So take advantage, is what I'm saying. Take advantage of the fact that this is a lighter week of assignments. We are going to look at Unit 7, Session 3, where we're going to find the area of a composition of figures. We call it composite figures, where we're putting a couple of different figures together. And then we're going to do the Unit 7 quiz, which covers sessions 1 through 3. So again, having this lighter week of assignments will be helpful, because if you are caught up, you can spend some time redoing some of the low-scoring assignments in sessions 1 through 3, which will also help you prepare for the quiz. So let's go ahead and review a little bit. Since we are taking the quiz this week, let's go ahead and review. And let's take a look at finding the area of regular polygons. So we looked at this last week, but I did just want to review this again. The formula for area of a regular polygon is 1/2 a times p. So let's make sure we understand what both the variables stand for. A is for the apothem. And P is for the perimeter. My pen is not writing super neatly this week. So P is the perimeter. All right, so what can we figure out about this regular polygon that we're going to find the area of? How many sides does it have? 1, 2, 3, 4. We are looking at a 5-sided regular polygon. Remember, regular polygon means all the sides have the same measurement, and all the angles will also have the same measurement. So it's a regular polygon. We know that each side length is 14. So can we figure out the perimeter? Sure we can. We just counted that there's 5 sides. So we know that the perimeter is going to be equal to 14 times 5. And what does that give us? 14 times 5 is 70. So we know that the perimeter is 70. Do we know what the apothem is? Remember, the apothem is going from the center of your regular polygon and straight down where you make a right angle with the base. That is the apothem. Do we have the apothem here? We do not. We need to figure out what the apothem is. So what we're going to do is we're going to create a right triangle and use what we've learned about right triangles to find the measure of the apothem. So what I'm going to do is I'm just going to, so our right triangle is going to look I'm going to highlight what the right triangle, this right triangle right here. What I'm going to do is redraw this right triangle below so that we can work with it and figure out the length of the apothem. All right, so we know that the length from here to here is 14. Half of 14 gives us the base of our right triangle. So half of 14 is 7. So I know the length of our base of our right triangle is 7. We need to figure out the apothem. So I'm going to label that A. So we're trying to find the apothem. What we can do now is find the angle measurement of our right triangle. So this angle right here, we can use, this is review, 180 divided by the number of sides, and that's always going to give you that angle measurement. So 180 divided by the number of sides in the polygon, we said this is a 5-sided polygon, so I'm going to take 180 and divide it by 5, and I get 36. So the angle measurement is 36 degrees. So now we can set up using a trig ratio. We can set up a trig ratio. And so what do we have in reference? So remember, we're going to use our reference point of the labeled angle. So we've got the opposite side in the the opposite and the adjacent. I just gave away. So that means when you have the opposite side and the adjacent, you're going to use the tangent. So I'm going to have tangent 36 equals the opposite side, which is 7, divided by the adjacent side, which is A. So A is in our denominator. We never want to solve for a variable in our denominator, so let's work on getting that out of the denominator. So I'm going to multiply A times both sides here, and that way we get it out of our denominator. Now we've got A times tangent 36 equals 7. And to solve for A, we need to divide each side by tangent 36. Whatever I do to one side, I've got to do to the other side. So I just type in my calculator 7 divided by tangent 36, and you should get A equals, I'm going to round to 2 decimal places, so 9.63. That's my apothem. So I have just found that the apothem is 9.63. I have the perimeter, and now I have the apothem, so I'm ready to go ahead and plug all those values into the formula for area. So let's go ahead and do that. Area, we know, equals 1/2 apothem times perimeter. We know that, I'm going to go ahead, the apothem is 9.63, and that the perimeter is 70. So I'm going to type in my calculator 70 times 9.63, and go ahead and type this in your calculator. Check to make sure you know how to enter this into your calculator correctly, so that you know how to do it when you go to do one of the graded assignments or the quiz. So I typed 70 times 9.63, and I got that product, and then I'm going to divide that by 2. And when I did that, I got 337. I'm going to go 2 decimal places, 0.05. And units squared. Since we didn't have any, I'm going to put units squared since it didn't say what we were working with here in terms of units. So that is the final answer. So I really wanted to review what you do when you're not given the apothem and you're given a side length. So that is the steps that you need to go through if you are given a side length but no apothem. There will be a problem like that on the quiz this week. All right, area of a sector, or sector area. We didn't talk about this a lot last week in the recorded session, but it was in the lesson slides. So I just wanted to go over how you find the area of a section of a circle like this. So you just follow the formula right here, where you take pi r squared and you multiply it times the central angle divided by 360. So let's go ahead and plug in our values. We're just gonna, it always helps to write down the original formula and then start substituting in the values. So pi times, what's our radius? 5. 5 squared is 25, so I could have actually written that as 25 pi. That you always want to put your number before pi, so let's go ahead and redo that. I know that my radius is 5. My radius is right here, so that's 5. 5 squared is 25, so we're going to have 25 pi times the central angle is 120 degrees over 360. So we would go ahead and keep going here. If I wanted to keep my answer in terms of pi, that means I'm going to keep pi in my answer. I'm not going to multiply it by 3.54. So let's do it both ways. Let's leave our answer in terms of pi first. So 120 divided by 360, then multiply that times 25, and I get 8.3 pi. Or if I don't want to leave my answer in terms of pi, I would take 8.3 and multiply it times 3.14. And I get 26.06. So when we leave our answers in terms of pi, we leave pi in the answer. That's what it means when we say in terms of pi. We leave pi in the answer. Okay. Composite figures. So here's an example of a composite figure. We've got 2 or more shapes creating a new shape. So if I were to make a line down here, I could see that I've separated this shape into 2 rectangles, right? I've separated it into 2 rectangles, which will help us when we go to find the area. So to find the perimeter, all we have to do is walk around, pretend we're walking around that shape, and add the numbers as we go. So we've got 1 plus, ooh, this side doesn't have a side length on it. What is that side length? Well, we know from here to here, we need to use the information that's given to us to help us find that side. So we know from here to here is 1.8. And then we know from here to here is 0.5. So if we take 1.8 minus 0.5, that's going to give us this length. So what I'm going to do is I'm going to take 1.8 minus 0.5, and that gives me 1.8 minus 0.5 gives you 1.3. You're just subtracting that 8 from the 5. So now, to find the perimeter, we're adding 1 plus 1.3. Then we're going to keep going here. We're going to add that 2. So plus 2. Then our next side is that 0.5. And then this whole length down here is 3 centimeters. So we're going to add plus 3, and that leaves us with that 1.8. So you want to make sure, even though all sides are not labeled, that if there are any missing sides, that you figure out using the given information the lengths of those missing sides. So you should have a length on every side when you go to add up the perimeter. So 1 plus 1.3 plus 2 plus 0.5 plus 3 plus 1.8. is 9.6. Perimeter, we would leave centimeters. We wouldn't square it when we talk about perimeter. We're just going to leave it as centimeters. So 1 plus 1.3 plus 2 plus 0.5 plus 3 plus 1.8. What about the area? For the area, we want to find the area of each separate. When I divide these shapes up, we want to find, so we know area equals base times height. So let's go ahead and find the area of this bigger rectangle, this rectangle here. So we do base is 1 centimeter, height is 1.8. So we multiply those two terms together, 1 times 1.8, That's pretty obvious what we get, right? 1.8. We're dealing with area, so we do centimeters squared. So that's the area of our smaller rectangle. So let's go ahead and circle that. What about, or bigger, I'm sorry. Let's move on to our smaller rectangle over here. Base times height, same thing. So we're going to do area equals, our base is just 2 centimeters. Our height is 0.5. So 2 times 0.5, and what do we get? If you said 1, you are correct. And that's centimeters squared. And then to find the area, we add those two together now. So area of the entire composite is adding the area of the two rectangles that we divided up. And we get 2.8 centimeters squared because we're dealing with area. So that's what composite is all about. Composite figures is, especially when you go to find the area, is to break them up into shapes that you know how to find the area of, find those areas, and then add those all together. So let's look at another one. Here's another composite figure. We've got, what two shapes? What two shapes are we dealing with in this composite figure? We've got a rectangle, right? We've got a rectangle, and then we've got half of a circle. We've got half of a circle. So let's go ahead and find the perimeter. So we've got two sides that are given. This side here is given. This side here is given, which means we know this side opposite. So if we know this side is 20 centimeters, the side opposite must be 20 centimeters. What about, and we also know this side length over here is 14, which means this side length must also be 14. So that helps us in finding, remember when we find the perimeter, we're really finding the circumference when we deal with circles. So to find the circumference, it's circumference equals pi times diameter. And we only want to find half, right? We're dealing with half a circle. So once we find the circumference, we can divide that number by half. So what is the diameter? The diameter is 14, and we're going to multiply that by pi. So let's go ahead and divide that by 2 now, because we know we're only finding half of our circle. We're only finding half of the circumference of our circle. So we want to take this now and divide that by 2. So I'm going to take 14 times 3.14 and divide that number by 2. And I'll round to 2 decimal places. And I got 21.98. So this is 21.98. So to find the perimeter, we're just going to add 14. We're only adding the outside. So we're not going to add this side length, only the outside. So we don't add this side to our perimeter. It's only the outside. So we're going to add 14 plus 20 plus 21.89 or 98 plus 20. Just the lengths on the outside, the perimeter of the figure. So plus 20 plus 21.98 plus 20. So we have 1, 2, 3, 4 sides. 1, 2, 3, 4. All right. So 14 plus 20 plus 21.98 plus 20. And I got 75.98 units. Not units squared, just units. We didn't have any units, so I'm just putting units so that we know. And then what about the area? So we're going to divide it in. It's already nicely, we've got this here, this line in here, so it's already divided into 2 shapes that we know. So what is our plan here? Let's go ahead and come up with our plan here. We're going to find the area of the rectangle, and then we're going to add to it plus the area of the half circle. So let's go ahead and do that. Area of the rectangle, to find that, it's base times height. So we're going to take 14 times 20. And what do we get? 14 times 20 is 280. And then we're going to add to that the area of half the circle. So to find the area of a circle, we take pi r squared. We know that the diameter is 14 of our circle, right? So what's half? So the radius is just half the diameter, which half of 14 would be 7. So we're going to take 7 squared, which is 49, times 3.14 times pi. So 49 times 3.14 is 153.86. So that's the area of the entire circle. Now remember, we only want half of the circle, so we need to take that number and divide it by 2. Don't forget to divide that by 2 because we're only dealing with half of the circle. And that gives us 76.93, and that is what we are going to add to that 280, is that 76.93. When we add those two numbers together, find the total area, or our composite area, is 280 plus 76.93, and we get 356.93. That is the total area of the composite figure. So we had to do some work before we could figure out that total area. So first we found the area of our area of the rectangle as 280, and then we found half of our circle was that 76.93, and you have to add those two together to get the total area. And again, that would be units squared. Do not forget units, especially when we're talking about area, it's units squared. So I'm going to go on to the next slide. If you need more time, please click pause now. All right, here's another composite figure where now we're kind of cutting shapes out to create a different type of composite figure. And we want to find the area of the shaded region. So let's figure out what shapes are we dealing with here. What shapes do you see in this composite figure? What shapes do you see? I see a rectangle. Good. What other shapes do you see? Half circles, right? There are two half circles. So really, if we put those two half circles together, we have one full circle. So how are we going to find just the area of the shaded region? How are we going to do that? Well, if we take the area of our rectangle, if we find the area of our rectangle and subtract out the area of the circle, that should give us, we'll be left over with just the area of the shaded region. So let's go ahead and do that. Area of the rectangle. What are we going to do? Base times height? Yep, we sure are. What's the base? 33. And what's our height? 16. So what's that give us a total area of? 33 times 16 is 528. So that is the area of our rectangle there, 528 units squared. What about the area of our circle? Area is pi r squared. Do we have a radius? No. Do we have what do we have for our circle? We know from here to here is 16. So if we move that over, we know that the measurement from here to here is also 16, right? So from that, can we figure out what the radius is? Yep, because half of that would be 8. So our radius is going to be 8. 8 squared is 64. I'm going to put 64 in front of my pi. So 64 times 3.14. Remember, I'm going to always use 3.14 when I go to type in pi. So 64 times 3.14, and I get 200.96. That's our area. So when we add those two together, or no, we're not adding, are we? We only want to find the area of the shaded region, so we're actually subtracting now. We are subtracting those. So we're going to take 528 minus 200.69. And what do we get when we subtract? Because we only want to find the area of the shaded region. And we get 327.86. 0.31, and again, that's going to be feet squared. We never want to forget units because we're dealing with area. That's why we have feet squared. So the final answer there is going to be that the area, when we subtract, so just of the shaded, is at 327.31 feet squared. And we're done. We are done. All right. So that's it. Ready for your key phrase assignment for the week. This is the week of 3-8. And what should we ask here? What should we go over? What did we go over? We talked about. So, explain in your own words what a composite figure is. And that's it. So you just need to answer this question to get your 10 points, and be sure to explain it in your own words from watching the recording this week. Have a great rest of your week, and please let me know if you have any questions as you're working on this week's assignments.